Hello, welcome to STEM Q&A. Today we'll be going over differential equation and more specifically first order separable equations. So to start off, this equation right here, dy over dx equals to a function of x over a function of y, is how you most commonly see these forms of equations. If you do a little bit of algebra, like moving the by to this side and the dx to this side, you can put it into this standard form right here. If you are able to put the separable equation into the standard form, to eliminate the dy and the dx, you can integrate both sides. And after you integrate both of these sides, you end up with the integral of by and the integral of a of x. Integral, antiderivative, however you want to say it. And after that, you end up with the constant, with the plus c at the end. And this plus c is any real number. It could be 1, 2, 3, -1, -2. It doesn't matter. Little key points is a of x must be a function of just x, so meaning no y's or any other variables. By, same, must be a function of just y. That means the opposite, like no x's. And in order to solve it, this must be true. What we mean by separable, the variables x and y must be separated into a form that can be integrated. So if you have like a y plus an x or an x times a y and you're trying to integrate that, you can. In higher level math, you can, but we're focusing on single variable separable equations. So to begin, we'll do one example. And the first example is xdx plus y dy. As you can see, this is very similar to a standard form, but you got x dx and y dy on one side, and to make this easy, we can subtract x dx to one side to put it into a standard form. So that's what we'll do. So after you see here, there's only on one side just y variables and on another side just x variables, and now we could just integrate. So integrate both sides, and using simple techniques, we get something like this. And we can't forget the plus c, which is, this means any real number. Okay, so if we want to get y alone, we just do the necessary algebra. So we can start by multiplying 2 to both sides. And key thing here, if I were to multiply a number to the constant, it's still a constant, it's still any real number, so we can still put plus c. And now to eliminate the y squared, we square both sides, square root both sides to be exact. And this right here is our general solution for the separable equation above. So to go over more examples, another example I have is this right here, y prime equals to x over y squared. Y prime is the same as the first order derivative of y, which can also be written as something like this. Dx over dy is the same as y prime, just means the derivative of a function with respect to x. So after we got this, as you can notice, this right here is very similar to what we have up here. Dy over dx equals to a function of x divided by a function of y. It's the same thing right here. So what we do is do a little algebra. Move y squared to this side, and the dy, I made a mistake here. This is dy over dx. So my mistake. So now we can move the dx to this side and the y squared to this side. And after this, we could just integrate. And simple integration techniques can be used. And once again, we could leave the y variable alone by just doing a little algebra, multiplying by 3, and then cube rooting it. So that's what I'm about to do. Plus c and now we can root it. So this right here is our general solution to the equation above, this one. Alright, so another example over here. So 1 over x dx minus 1 over y dy. So as you can see, this is almost in standard form. All we have to do is add something to one side, and in the end we'll get we get 1 over y dy equals 1 over x dx. So using integration techniques, when you got a variable to a -1 power or 1 over y is the same thing, this would just be natural log of whatever variable there is. So natural log of x. And we can't forget the plus c. Now to eliminate the natural log, what do we need to do? We need to use e. So we e both sides. And then on this side, we just have y. But on this other side, we have e ln of x plus c. And there's some power rules that we use to simplify this. So if you got e to the a plus b, this is similar to e to the a times e to the b. So this right here is just equal to e to the ln of x times e to the c. So remember, you got e to any number, that's just a constant. So we could just write e to the c just like c. And the e cancels out the natural log, so we're just left with an x. So y equals c times x, and that is the general solution. General solution to the equation above. Alright. So a couple more examples. I'm gonna give you an example of something that may look separable but really isn't. So to see why it's similar, we could try it out. So we could subtract the y to the other side to leave the x variable alone. So this is actually a minus, my bad, equals to x. As you can see, if we wanted to move the dx to the other side, we'd have to multiply dx on both sides. We could try that. And as we know, we can't integrate y respect to x. So this simply isn't separable and cannot be solved. Not separable. So if they ask find the general solution of an equation looking like this, the answer would just be not separable. So another thing that looks very similar but actually is separable would be an example like this, x times y. So this right here is separable. So what we do here, we just divide y to the other side and multiply dx to the side where the x is. So we got 1 over y dy equals x dx. And using simple integration techniques, integrate both sides. This is just ln of y equal to x squared over 2 plus c. And then now, what can we do here? Use e to eliminate the natural log on this side. So now we just have y equal to e to the x squared divided by 2 plus c. And remember from the power rules, this just equals to c times e the x squared divided by 2. As you can see, we didn't have a natural log that could cancel out the e. So this would just be your general solution to this equation. So that is it. Thank you for watching. Please like and subscribe. Please feel free to leave questions in the comment section below, and thank you for watching.